Look at the next question. It says a measuring instrument is used at points P and Q on the same horizontal level to measure the angle of elevation of the top T of a hill. Given that P is 5,200 meters above sea level, PQ is 4,000 meters, and the angles of elevation of P and Q are 15 degrees and 35 degrees respectively. Calculate the height of the mountain. Okay, so the first thing we'll do now is to take the mountain or the hill. This is the hill. Call this the hill or the mountain. And then they say a measuring instrument is used at points P and Q on the same horizontal level. P and Q are on the same horizontal level. And it is used to measure the angle of elevation of top T of the hill. The top of this hill is T. Given that P is 5,200 meters above sea level. So if we assume that this is sea level, we said P is 5,200 meters above sea level. So distance from here to here is 5,200. Okay. So P is 5,200 meters above sea level. And we also told that P and Q are on the same horizontal level. So point P and point Q are on the same horizontal level. And distance between P and Q is 4,000 meters. The distance PQ is 4,000 meters. So I will indicate that distance between P and Q is 4,000 meters. Alright. Now they said the angles of elevation of P is 15 degrees and that of Q is 35 degrees. They say angle of elevation of P and Q is 15 degrees and 35 degrees respectively. So I'll take that P with respect to the top of the hill. The angle of elevation is 15 degrees. And then Q with respect to the top of that hill, the angle of elevation is 35 degrees. Alright? Alright, and distance between P and Q is 4,000 meters. That's distance from here to here. It's 4,000 meters. Distance between P and Q. And the angle of elevation of P with respect to the top of the hill is 15 degrees. And that of Q with respect to the top of the hill is 35 degrees. Alright? And then they said P is 5,200 meters above sea level. That's why I have this height. Calculate the height of the mountain. The height of the mountain. So the height of the mountain is distance from here to here, which we can call height H. We can call it H, the height of the mountain. Okay, that's the mountain or the hill. Okay. All right. You see here is P and there is T. Here is Q. I can call here X. I can call here Y. I can call here Z. All right. Okay. So what's the next thing I'll do now? Distance from here to here is 4,000, and I can say distance from here to here is small y. Okay. From here to here is small y. So if that is the case, then implies that the full distance from P to Z will be 4,000 plus y. That's from P to Z. If distance from here to here is 4,000 and here to here is y, the total distance from point P to point Z is 4,000 plus y. So I'll add them. I'll add it. Alright. Now what's the next thing I'll do? Okay, this is 90 degrees. It's angle 90. So that will be, I can cut out the triangle QTZ. I can cut out this triangle, solve, then later I cut out the full triangle and solve as well. I say from triangle QTZ. Now before that, let's come back to this diagram. If distance from here to here is 5,200, it also means that the distance from here to here as well is also 5,200. Okay? Yes, this is Z. This point is Z. Point Z. That is Z, capital letter Z. Okay? Okay, so that is it. So if distance from here to here is 5,200, That means that point from Z to Y is 5,200 meters as well. That they are parallel to each other. They are of the same length. So if this is 5,200, I can then imply that the distance from here to here is x. It's x. Okay? So if that is x, that means that the height now will be total, the height which is this small h will be equals to 5,200 plus what? Plus x. Okay? Okay, that's it by the way. Now I can then cut out this section. I say from triangle QTZ, and if I cut it out, if I section this out now, this is QTZ, QT and Z. This is 90 degrees at this point, angle 90. At that point there is 90 degrees. That is QTZ. That's 90 degrees. Then here is 35 degrees. And this distance is Y. And here is X. Okay, that's it by the way. Now what do I do? I say this side which is facing angle 35 degrees is my opposite side, because this is an angle of inclination. This is 90 degrees. The side facing 90 degrees is hypotenuse. Okay, it's hypotenuse. And the remaining side now will be what? Adjacent. Okay, so it then implies that I can use opposite over adjacent, which is tangent. So that is tan. Okay, I say tan 35 degrees equals to opposite side over adjacent. Okay, opposite over adjacent. That's opposite over adjacent, and that will be the opposite side is TZ. The adjacent is QZ. TZ is X. And QZ is Y. So I'll cross multiply this, will multiply this. Now I'll have that X is equals to Y tan 35 degrees. That is when this multiplies this, then X will come down. This one has a denominator of 1. That is X times 1 is X. Y will multiply tan 35. That is Y tan 35 degrees. Okay, right? So I have X equal to Y tan 35 when I cross multiply. All right, now I will then continue. The next thing I'll do is to take this triangle, take the full triangle. Now the full triangle is triangle PTZ. Take the full triangle PTZ, and that will give me, say from triangle PTZ, that will be, I can call this one equation 1. So from triangle PTZ, that will be big, it will be, so I say from triangle PTZ, this is it. This is what to give me. PTZ, this is point P, and this is point T, and this is point Z. This is 90 degrees, and this angle here is 15 degrees. This is X, and distance from P to Z is 4,000 plus Y. Okay, now say that the side facing angle 90 is hypotenuse. This side that faces the angle of inclination is opposite. Yes, this is opposite to this angle, and here now is adjacent. Right? Okay, this was what I did. I just took out that triangle PTZ, cut it out. That's it. So I can say opposite of adjacent is tangent. I say tan 15 degrees is equals to opposite over the adjacent side. My opposite side now is opposite is TZ. Over the adjacent side is PZ. So distance TZ is X. PZ is 4,000 plus Y. So if I cross multiply now, this will multiply this. So I have X is equals to 4,000 plus Y multiplied by tan 15. Okay, so that is it. Now if I expand this, 4,000 multiplied tan 15, that will be what? 4,000 tan 15, and y will multiply tan 15, that is plus y tan 15 degrees. That's, I call this one equation 2. I call this equation 2. So x is equals to 4,000 tan 15 plus y tan 15 degrees. That's equation 2. Now what I do next is to equate equation 1 to 2. So equate 1 to 2. So if you come over here, this is equation 1, x equals to y tan 35. And this is equation 2, x equals to 4,000 tan 15 plus y tan 15. As I'm kind of saying x is equals to x, and x over here is y tan 35. That is y tan 35 degrees equals to x over here is 4,000 tan 15 degrees plus y tan 15 degrees. Okay, so if I collect like terms now, take this one over to this place, I'll be having y tan 35 degrees minus y tan 15 degrees is equals to 4,000 tan 15 degrees. Okay, as when I carry this one over to this place, I collect like terms. Take this over here. Since it's positive, once it crosses the equality sign, you change to negative. Then I can then factorize. Y is common. I factorize y out, and I'll be having okay, so if I factorize that now, the common factor there is y. So I'll be having I'll have y open brackets tan 35 degrees minus tan 15 degrees. Okay, it's equal to 4,000 tan 15 degrees. Okay, so I divide by the coefficient of y. Coefficient of y is this. So if I divide by the coefficient of y, y will be equals to 4,000 tan 15 degrees divided by tan 35 degrees minus tan 15 degrees. Okay, so this now will give me, so equals to 4,000 times tan 15 will be, so that is 0.268 divided by, okay, I'll look for tan 35. Tan 35 will give me this will give me 0.7002. Okay, so when I multiply this now, it will be y will be equals to, if I multiply that, I'll have when I multiply that, I'll be having 1072 divided by 0.7002. So when I divide now, I'll be having this one will give me 1530.9 meters. Okay, that's the value of y, 1530.9 meters. So I can substitute y, the value of y, into equation 1. So I say substitute y equals to 1530.9 meters into equation 1. Okay, so that I can find the value of x. So if I substitute to equation 1, I'll be having x equals to y tan 35 degrees. That's equation 1. Okay, so now this will be x equals to, in place of y now, I will replace it with 1530.9. So in place of y, I will write 1530.9. Okay, this is tan 35 degrees. So in place of this y, I write this 1530.9. That's the meaning of substitution. Substitution means replacement. So that means x will be equals to 1530.9 times tan 35 will give me, this is 0.7002. Now x now will be equal to, multiply that will be, this will give me 1071.9 meters. Okay, that is x, 1071.9 meters. So I can then say the height, said the height of the mountain, the height of mountain, which is h will be equals to x plus what, 5200. Okay, that is it. If you observe, that's the height of the mountain, that is x plus 5200, which is h, that's distance from here to here, is x plus 5200. X plus 5200 is this distance from this point to this point, y. So that is x, the value of x is 1071.9 plus 5200. So h now will be equal to, if I add them, I'll be having, this will give me 6271.9 meters. This is the height of the mountain, 6271.9 meters. Okay, 6271.1 meters. That is the height of the mountain. The height of the mountain has been obtained, 6271.9 meters. Alright, so we'll stop there. Stop there for now. We have derived what we want, the height of the mountain. This was all the solving that we did. Everything we solved. Okay, so that is it. Everything we have solved here. Okay, so we see that we had to obtain the value of y. We had y as 1530.9 meters, and then we went on to equation 1, and we substituted the value of y into equation 1. That is it. Substitute y equals to this into equation 1. Finally, we had the value of x as 1071.9 meters. Then the height of the mountain we solved, and we got the height of the mountain as 6271.9 meters. Alright, thank you. Thank you. Okay, we have another question on the board. It says, a flagpole and a building stand on the same horizontal level. From the point P at the top of the building, the angle of elevation of the top T of the flagpole is 65 degrees. From the top Q of the building, the angle of elevation of the point T is 25 degrees. If the building is 20 meters high, calculate the distance PT, the height of the flagpole, and distance QT. So we'll start with that. A flagpole and a building stand on the same horizontal level. So we come here, this is the horizontal level. So we can say that this is the building. This is the building. And then this one is the flagpole. You can call this the flagpole. Okay, alright. So both the flagpole and the building stand on the same horizontal level. Then it goes on to say, from the point P at the bottom of the building is P. The angle of elevation of the top T of the flagpole, the top of the flagpole is T. Angle of elevation of the top T of the flagpole is 65 degrees. So from this point P, I'll go down, extend it to point P. If I extend it to point P, so from point P, it says at the bottom of the building, the angle of elevation of the top T is 65 degrees. So from point P, angle of elevation is 65 degrees. Then from the top Q of the building, the top of the building is Q. So from the top Q of the building, the angle of elevation of the top T is, so from this point, okay, it says from the top Q. So from the top Q of the building, the angle of elevation of point T is 25 degrees. 25 degrees. So take notes from the top Q. So since it is from here, I'll take my angle of elevation here. The other one, it says from the point P, the angle of elevation is 65 degrees. So that's what I have. Now it says if the building is 20 meters high, so the height of the building is 20 meters. If the building is 20 meters high, that is, the height of that building is 20 meters. Distance from here to here is 20 meters. Building is 20 meters high. It says calculate the distance PT. Find distance PT. That's distance from P to T. We'll look for that distance PT. And then also calculate the height of the flagpole. The height of the flagpole is distance from here to here. You can call that small h. Small h, which is the height of the flagpole. Okay. And then they say find the distance QT. Distance QT is distance from here to here, which is QT. Distance QT. Alright. Distance QT. Alright, then. Alright, let's do that. Now, if this is 65 degrees, it will alternate at this point. 65 will alternate here as 65 degrees. Okay, alternate angles. This will alternate this. Okay, 65 degrees, that's correct. Now, we'll look for this other angle. If here is 25 degrees, you can find here 90 minus 25, and then we'll be having a. Okay, so 90 minus 25 will give me 65 degrees. Okay, that's 65 degrees. Now, if this is 65 degrees, here will also be 65. That's it. So this will alternate here at 65. So I can then add them. 65 plus 65 will give me 130 degrees. Okay, so that's it. And if this is 25, this will alternate here. To alternate here as 25 degrees. This is it. Alternate angles here will be 25 as well. So this angle is alternate to this angle, 25, 25. Alright, so I can then say that here is angle 90 degrees. That's 90 degrees. Okay. Now let's quickly look at that. If here is point T, I can choose to call this side M. Okay. Now what's the next thing we'll do? I can then take the triangle TP. Can call here Y. TPY. Solve, look for this H. And then you observe that I can't actually find H until I find this distance. So the next thing I'll do is to take triangle TQP. Let's start from that. You see, from triangle TQP, that is this triangle TQP. Okay, triangle TQP is that triangle over there. So if I take it out now, we're having a triangle T, Q, and P. Angle at T is 130 degrees. Angle at Q is 25 degrees. And then angle at P is unknown. Though I can find that angle. You come over here. Of course, we know that 90 minus 65 here will be 25 degrees. Okay, so that is it. So if that is 25, that means this is 25 degrees as well. And then we know that distance QP is 20 meters. That's the height of the building. The height of the building is 20 meters. That is it over there. The building is 20 meters, so I will indicate it 20 meters. Then I can find this side PT, and I can also find this side QT. Alright, so if this is capital T, this side now will be small t. Capital P, this side facing it is small p. Capital Q, this side facing it here is small q. Okay, so we can then apply sine rule. Using sine rule now, we're having a, so I say using sine rule, apply sine rule to this diagram. So I'll have a sine q over small q equals to sine p over small p equals to sine t over small t. Okay, so let's do that now. This is sine angle at q. The angle at q is 25 degrees. That's 25 degrees over small q. Small q is pt. Distance pt is equals to sine angle at p. Angle at p is 25 degrees over small p. Small p is distance qt equals to sine angle at t is 130 degrees. 130 degrees over small t is 20 meters. Now I'll then compare this to this and compare this one to this other equation. So I'll be having what? Sine 25 degrees over distance pt. I compare this one and this one is equals to sine 130 over 20. Compare this to this. So this is what I have. I cross multiply. If I cross multiply, I'll have, so I'll go and I say cross multiply. So if I cross multiply now, this will times this one will times this, and I'll be having this times this. I'll have distance pt sine 130 degrees equals to 20 sine 25 degrees. So if I make pt subject of formula, distance pt now equals to 20 sine 25 degrees divided by sine 130. So this will be equals to 20 times sine 25 will give me this is 0.423 divided by, I look for sine 130, that will be, this will give me 0.766. So I can then multiply it. I have distance pt as 20 times 0.423. This will be 8.46 divided by 0.766. That will give me 8.46 divided by 0.76. If I divide this, to give me 11.04 meters. Okay, so that is distance pt. So distance pt is 11.04 meters. Now the next thing I'll do is to find distance qt, and then that is, say, distance. So therefore distance pt equals 11.04 meters. Now how do I find distance qt? I'll come back to this diagram, still use sine rule, that is over here. Now I'll compare this to this, that is sine 25 over qt equals to sine 130 over 20. Let's compare these two. That is sine 25 degrees over qt, and 25 degrees over qt is equals to sine 130 over 20. So when I cross multiply this, we multiply this. That's qt sine 130 degrees equals to, this one multiply this one, is 20 sine 25 degrees. Okay, so if I divide by the coefficient of qt, distance qt is equals to 20 sine 25 degrees divided by sine 130 degrees. This will give me 20 times sine 25 will be This will be 0.423 divided by sine 130 will give me 0.766. Okay, so 20 times 0.423 will be, that will give me, this will be 8.46 divided by 0.766, and that will be, the value there will be is equals to 11.04 meters. Okay, so therefore distance QT is 11.04 meters. Okay, all right, it's 11.04 meters. So I've gotten that distance QT is 11.04 meters and distance PT is 11.04 as well. Okay, so I can say from triangle TPY, that will give me, if I cut out this triangle TPY so that I can find the height, here is the height. We had distance PT as 11.04 meters. Okay, this is T, this point 90 degrees over here, and this is Y, this is Y, and over here is point P. This angle at this point is 65 degrees. Angle at this point is 65 degrees. Alright, that's 11.04 meters. Okay, so at this point now we can find the height. So I say the side facing 90 degrees is my hypotenuse side, and this side facing the angle of inclination is opposite, and then the remaining side becomes what? The adjacent side. Alright, okay, so this is opposite and this is hypotenuse, so that means I can make use of so since I am looking for this opposite side, which is H, so I say sine 65 degrees, sine 65 degrees will be equals to opposite over hypotenuse. That will be opposite over hypotenuse. The opposite side now is H, and the hypotenuse is 11.04. Okay, that's H over 11.04. If I cross multiply this, we multiply this, that means the height H will be equals to 11.04 sine 65, this times this. Okay, that means H will be equals to 11.04 times sine 65 will give me, it will be 0.9063. It will be equal to H equals to 11.04 times 0.9063 is this will give you 10.01 meters. So therefore the height of the flagpole is 10.01 meters. That's the height of the flagpole. It's 10.01 meters. Alright, the height of the flagpole is 10.01 meters. When you multiply, you get that to 2 decimal places. Alright, so we'll stop there. Okay. Stop there. This is the diagram, the flagpole and the building. The height of the building is 20 meters, while the height of the flagpole is 10.01, which is approximately 10 meters. So that's everything we did. you also observe that distance QT and distance PT is the same. Distance PT is 11.04 and distance QT is also 11.04 meters. Okay. The height of the flagpole is 10.01 meters. Alright, stop there. Stop there for today. Okay, thank you.